Welcome to another episode of Environmental Digest. Today we are going to talk about a groundbreaking way to clean our water using nothing but sunlight and sound.
All right, so let's just jump right in. We all need clean water, right? It's fundamental. But here's a wild thought. What if the very process we use to clean our water is actually creating, well, its own set of problems? Turns out some of our go-to methods, like chlorination, can actually create some nasty byproducts. Yeah, byproducts like trihalomethanes, they can be really hazardous to our health and to the environment, and this just highlights how badly we need better, cleaner solutions. Which brings us right to the heart of the matter, our polluted water problem and the urgent search for a safer way forward.
So what are scientists doing about this? Well, they're tackling it with something called advanced oxidation processes, or AOPs for short. You can think of these as superpowered chemical treatments. They're designed to destroy even the most stubborn, the most recalcitrant pollutants by unleashing these incredibly reactive little things called hydroxyl radicals.
And this is where things get really cool. We're talking about a super innovative AOP that combines two forces you're probably pretty familiar with. So let's check it out. A sound and light solution. Introducing sonophotocatalysis. Okay, sonophotocatalysis. I know, it's a bit of a mouthful, but the idea is actually pretty simple. It's a hybrid approach, right? It takes two things and smashes them together for a better result. You've got photocatalysis, which uses light, and sonocatalysis, which uses sound waves.
So the big question is, how does it actually work? What are the mechanics of combining sound and light to pull this off?
Okay, this diagram might look a little complicated at first glance, but trust me, the idea is really straightforward. So first up, you have sunlight. That's the photo part, and it hits a catalyst material. You can think of it like charging up a battery. It's giving it the energy it needs to get to work.
But the real magic is when you add the sound. The ultrasound waves do a few amazing things all at once. They help create even more of those pollutant-busting radicals, and at the same time, they're literally shaking the catalyst surface. This keeps it clean, stops it from getting gunked up, and makes it way more efficient. It's this one-two punch that makes the whole thing so powerful.
So what you get is a process that's, well, it's way more than the sum of its parts. This isn't just 1 + 1 = 2. It's more like multiplication. And that, right there, is the power of synergy.
But you might be thinking, okay, is it really that much better? Is the combined process truly more effective than just adding the two individual effects together? Well, the answer is a big, resounding yes. And scientists actually have a way to measure this. It's called a synergistic index. The rule is pretty simple. If the index is greater than 1, it means you're getting a real bonus effect. And in one study, the number they got was pretty incredible. It was 3.7. So what does that number actually mean? It means the combined process was nearly 4 times more effective than what you get just by adding the separate effects of sound and light. That is a massive boost. And this chart really drives it home. Look at this. Photocatalysis by itself, maybe it gets rid of 15% of the pollutant. Sonocatalysis alone, just 10%. So you'd think together they'd got, what, 25%? Nope. Look at sonophotocatalysis. It jumps to a staggering 85%. That's what that synergy looks like in action. It's a total game changer. Okay, so this is obviously a dramatically more powerful solution. But, and there's always a but with incredible new science, right? The real challenge is always getting it out of the lab and into the real world. So let's talk about the path from lab to reality. And there are definitely some big hurdles to overcome before we see this in our local water treatment plants. So you've got some major challenges. For one, the ultrasound part uses a lot of electricity. Then there's the problem of getting sunlight to actually penetrate murky, cloudy wastewater. Plus, you have to develop catalysts that are stable, cheap, and reusable. You can't just keep throwing them away. And maybe the biggest hurdle of all is just plain engineering. I mean, look at the difference here. On the left, you've got a typical small batch reactor you'd find in a lab. But on the right, that's the kind of continuous flow system you need to treat massive volumes of water in the real world. Making that leap, that's the next big, crucial step. But look, despite all those challenges, the potential here is just immense. And I think this quote from researchers Bagal and Gogate really sums it up perfectly. They say it offers a comprehensive approach to deal with the messy, complex mix of pollutants we actually find in real wastewater. So that really leaves us with a powerful question to think about, doesn't it? Could the future of clean water really be powered by something as simple as the combination of sound and sunlight? It's a thought that gives me a lot of hope for a cleaner, more sustainable future. Thanks for joining me for this explainer.